Welcome to Module 1 of the 16S Microbiome IBT course. Here we'll be introducing you to R and R Studio, which are powerful tools for statistical analyses and generating publication quality graphics. So firstly, why are you going to love R? When I first started using R, it was out of necessity for my own PhD project. I had no programming experience, and initially there was a steep learning curve for me, and then eventually it turned into the single most useful tool that I currently use in my statistical analyses and plotting. And the reason for that is because there are so many specialized packages for different areas of research, and they're all open source that you can apply to your own project. So what is R? R is an open source programming language used for statistical analyses and graphics. So R Studio is a user-friendly interface that we'll be using to program in the R language. R Studio allows you to see your R script, where you'll be recording all your commands, your R console, as well as all the graphics in one screen. And we'll be going through this step by step in the next lecture. R Studio also allows you easy package installation to update old packages, and it also has help files for each package and function that you install. R Studio, one of its most important features is that it allows code reproducibility, and that is important for research and publication. So why should you learn R as opposed to commercially available statistical software that might be easier to use initially? So when we think about non-programming point-and-click software, they can actually be dangerous. And the reason for this is because you might not be entirely sure of what you're doing. You're doing a point-and-click, and this analysis has a certain name, but do you really know step by step what is happening in between? So R is a series of written commands, and this has several advantages. So you have to think about what you're writing and know what each command is doing. And your analysis is also now reproducible. Because you've written each command in an R script file, you can save this and you can send it to collaborators, and also more and more journals require that you actually submit your R script file for your analyses, so that other users can see if they can reproduce your results. As I said, easy collaboration. If you want to share your analyses with collaborators, you can do that very easily by sending them the R script file. Or if you're stuck on a certain piece of code and you don't know why it's not working, you can send it to someone to help you troubleshoot. And like I mentioned, R has specialized software packages that are likely only available through R and not commercially. You might be working on 16S microbiome data like we're going to be doing. And for this, there's several custom R packages, such as PhyloSeq and MetaGenomeSeq, and we'll be working with both of these in a later module. One of the most fun things about R is that you can create publication quality graphics. They're highly customizable, and they can actually be quite fun. Let me show you some examples from my own work. So in this example, this is actually 16S microbiome data, and the rows we see here, each one is one individual sample, and then for each sample we've got one bar plot summarizing the bacterial composition for that individual. At the top, we've also added additional information relevant to each individual. In this case, it was something called BV status. And imagine this is a powerful feature of R because it allows you to represent both microbiome data and other clinical information relative to your samples all in one plot. This is another example of 16S microbiome data. In this case, we have a heat map where colors that are more red represent higher abundance, and the blue colors represent lower abundance bacteria. So each row you see here is one taxonomic unit, and then again at the top we've added clinical information that are relevant to each one of these samples. So you can see we have hundreds of samples here. And in this case, this plot really allowed us to see how strong the relationship was between inflammation and bacterial profile. So you can see there are several bacteria that are highly abundant only in samples that also have high levels of inflammation. So it's a really nice way to explore your data. So the only way to really get good at R is to dive in the deep end and just start coding. You are going to get stuck along the way, but you can actually just ask Uncle Google, because you can be sure if you've had a certain problem or an error in your script, someone else has had it too and they've posted about it. There's a large R user community with plenty of user forums that you can go post your specific error that you have, and more often than not, a very helpful user will come to your rescue. If we look at this plot from Stack Overflow, which is one of the websites that you can go ask questions, you can see the growth of R over the years in the number of queries that people have posted there. I'll show you an example. In this instance, the person was importing some data into R, and they got X's in their column names and they couldn't figure out why. They posted a reproducible example so that people could see what exactly was happening, and someone came to their rescue and helped them out and answered them and said, actually, if your header contains labels that are not syntactically valid, then the make names will replace them with valid names, and it'll add the X to your column name. So that is why, and then the user can say, okay, thank you, and there you go. So let's look at our syllabus and our learning objectives for this module. We're going to do an introduction to R Studio. We're going to define the following terms as they relate to R. What is an object? What does it mean to assign? What is a function? And what are arguments in functions? We're also going to learn how to import data into R as data frames, which is really one of the key skills that you need if you're importing your own data that you need to analyze. Very common in R, subsetting, indexing of data frames causes some confusion, and we're going to show you how to do it easily. And one really important part is best practices for writing R code. So it's all good to dive in the deep end and start coding, but you really want to start your coding with good practices for reproducibility and learning how to structure your code so it's easily readable for other users that you might share your code with. Our outcomes for this module: we want you to be really comfortable navigating R Studio, and we want you to be comfortable with basic R operations and syntax. Lastly, we want you to be confident importing your own data into R in the right format. So I've actually created a website for this module, and here we can see all the syllabus content that we're going to be working through, and I've also included some useful links for you that are not in the presentation. So the material we're using is actually part of the Data Carpentries organization. You can have a look at them here, and this material can be freely used and shared. They have a whole variety of courses that you may be interested in, but for the purpose of this module, we'll be focusing on R and R Studio. So you should now already have R and R Studio access via your own compute cluster that should be provided by your system administrator. And in the next lecture, we'll be introducing you to R Studio.